from 34 CSV, we have identified the MITRE technique to be T1046 Network Service Discovery. As you can see, we use this filter above, and the source is 192.168.32.128, and it scans the port one time for every port at 192.168.32.130 base, and this can be seen from the line chart. So from 86.log, we can see that there was a brute force attempt, as there were a high number of failed logging attempts, especially from IP 192.168.206.251, which is a strong indicator of brute force attempt. Next, we can see external remote services. There were repeated unsuccessful attempts to gain access via SSH from external IP address, indicating potential unauthorized attempts to access the system. So the behavior of repeated failed attempts to followed by a successful login indicates the external entity might have finally succeeded in gaining access, possibly through guessing or using stolen credentials. This pattern suggests potential malicious activity related to the T1133 technique, which is external remote services. Next, we identified MITRE technique, which is valid accounts, where a successful login from IP 192.168.206.251, which had many failed attempts. So from 87.log, we mapped the MITRE technique valid accounts. Based on this figure, it shows an example of logs indicating multiple use of sudo and su by the user Darius to elevate privileges. There are many more instances of sudo and su that's being used, but if this is unexpected, it could indicate that there's an unauthorized user gaining root access, and if the use of sudo for Darius is not typical, it might suggest a misuse of valid accounts. The next MITRE technique will be abuse elevation control mechanism, which shows, and from this figure you can see that the pkexec command allows an unauthorized user to execute commands as another user. Next, MITRE technique is abuse elevation control mechanism, and the subtechnique is sudo and sudo caching. So again, it shows the user Darius has privilege execute commands as root using sudo, and can be seen use this privilege and open a session as the root user. Next, MITRE technique is create account, and the subtechnique is local account. So this shows that after opening a session as root user, it created a new local account with the name SUSS. MITRE technique will be credentials from password stores. So you can see that there is attempt to change the password of the login keyring without providing the old password. Hence, this can be seen as suspicious, as is typically not in line with the user activity, and a legitimate user would know the old passwords if they were attempting to change it. The next MITRE technique is scheduled task or job, and the subtechnique is cron. So we can see logs with regards to cron daemon starting and stopping sessions for the root user. The next MITRE technique will be account manipulation, which shows that there were local accounts that created, and it added the sudo group and then allowed the user SUSS to access administrative privileges.
Okay, for 52B CSV, it will firstly be cleaned and sanitized with a Python script, and this can be found in our GitHub repo. For this CSV, there are many process creations and terminations which indicate that it might attempt to do defend evasions. Firstly, what it does is try to download a non-official Chrome browser. You also try to do persistent method by creating a user account called user, and also run Microsoft Edge executable and disable phishing detection. You can see for this code itself, what it does is trying to ping to a base64 encoded payload, and when it's decoded, it's trying to download a non-official Chrome executable, and this Chrome executable also will be run silently in the background of the victim. And also, we attempt to create a user called user, which will be used as a form of persistence to the victim as well. And lastly, there's a code where it will attempt to run a Microsoft Edge executable with the flag to disable client-side phishing detections. So this might indicate that the attacker is trying to attempt to do phishing.
For 52.178.csv, we have identified that there was use of command scripting interpreter PowerShell. So they use PowerShell to execute the script. Next is reflective code loading. There was a base64 encoded string, which is presumably a PE file, and so later we decoded it and stored it. It decodes it and stores it into memory. So overall, it loads the DLL directly from memory and not from the disk. Next, we have process injection. We've identified MITRE process injection, which actually injects shellcode into memory of a newly created process. Next is obfuscated files or information. It obfuscated the files and information using base64. And next is hijack execution flow, which actually created a lot of processes. This is the obfuscated part where it shows the base64 encoding, and this string is very suspicious. So upon decoding it, we managed to see all these things, and we have identified that this can be seen as that the script uses get proc address to find the addresses of certain functions such as virtual alloc, create thread, and wait for a single object in the connect32.dll library. So these functions were invoked, and which allocates memory, creates new thread, and basically waits for it to finish execution.
For the brevity of this video, we'll be skipping the exploratory data analysis portion of this log. A thorough explanation on the EDA part that's covered on the report can be seen there. We'll now fast forward ahead to using this filter on Kibana, which yields us the following result. From the results, we can see that the HTTP requests are made to the server with a destination IP address of 169.254.169.254. These requests are attempting to access specific URLs under the path latest metadata IAM security credentials, but all these requests are resulting in a 404 not found response. We then followed the source IP address, which is 10.0.0.1.15, and filtered out the request with this filter. The resultant output shows us a GET request to a potentially sensitive endpoint that could be used to capture or display IP addresses, by also trying to access specific path, which is more specifically latest metadata IAM security credentials. It suggests that the attacker might be looking for files or resources containing security credentials. We can associate this to the potential meter attack technique T1555, which is credentials from password store.
Okay, so in this portion, we will do a simple demonstration on the MITRE attacks that we have implemented. In order for us to see the logs matching with the MITRE attacks, I will put the timestamp in which the attacks start and the attacks end, so that it's easy for us to reference later on. In the initial phase, we will do the nmap, in which we will nmap the victim's target IP, and we will see what comes out from the results. Alright, so we can see that the victim is running two ports open, 22 and 80 is running a Apache server. So we need to know whether the Apache server is vulnerable, and we have pre-written a script called apache vuln.py, which is a Python script that allows us to check the vulnerability version of the Apache and do a path traversal on our behalf as well. Running the script allows us to see the possibilities within the Apache server, and from here we know that the vulnerability is accessible, and it prints out the PASSWD file for us. Now we can see that RCE is possible, and from RCE we know that we are able to do a reverse shell script if a remote code is being executed. So we just do a simple echo into the TMP file, which allows us to execute the bash script. So I just want to complete the bash script over here, in which we will echo it to port 4444 on our host PC. On the other tab, we will just simply listen out to port 4444 for the reverse shell to happen. And we just paste in the bash script to execute the reverse shell command. So as you can see over here, the reverse shell is successful, and we are able to get inside the user daemon of the Apache service. So you can see that there's a add and the service number, which indicates that I'm in the Docker. So I just want to explore around inside the Docker to see what information I can find to exploit. The home directory normally stores information that are useful inside documents. And we can see that within documents, there's a cloudvm.txt. Let's cat that particular txt file out. And we can see that there's a link to a Google Drive. So upon following the link, we can download the PM key from the website. So cross-referencing the PM key with the PSSWD, we know that the common user is called CloudVM. So let us attempt to SSH the CloudVM user with the PM key downloaded previously. We just have to add the victim's IP address over here. Successful entry into the VM shows us that we are no longer within the Docker, and we are able to execute other exploits. The other exploit that we're going to execute right now is to collect system information from the Cloud VM itself. In order to create system information, we simply just have to create a bash script called sysinfo.sh and paste the script into it. We have to run sudo first. And the information should be printed out into systeminformation.txt. So I shall now attempt to cat out the systeminfo.txt, as you can see over here. And these are the information that we have extracted out from the victim host. Next, we are moving on to extraction of password policies within the victim host. So we just have to create a new bash script, paste the bash script into the password policy.sh, and then execute the bash script with sudo permission. These are all the information that we have extracted out from the system, and as you can see, password policy.txt has been created with the information echoed into it. Now we are moving on to our final exploit, in which we will create an exfiltration bash script. So the exfiltration bash script will attempt to use the scp command to copy the files from one area, which is the target host, to my listening host, which is the attacker side. So we just save this bash script as exfil.sh and execute the file with sudo permission as well. Click yes, connecting, enter the password for the attacker host, and we are able to see the progress of it being sent over to the target host. File transfer successful will be printed out if your file transfer is indeed successful. And see, we are able to cd out and see that the two files exist within the directory, password policy as well as systeminfo.txt. So catting it out shows that it's the same exact thing that was printed out in the target host, and catting systeminfo out shows that it is indeed the information that got sent over. Now that all that is done, we have completed our attack simulation.
The dashboard capture here shows the logs based off our meter attack. It looks at the Docker logs, and based off the dashboard, it captures reverse shell commands, and this link to the MITRE ATT&CK on exploiting public facing application. Any form of script that has been run will be captured in our log as well, and two script has been detected. This link to potential MITRE ATT&CK on unique shell scripting. We have also set audit key that key to different thread. For instance, any attacks that deal with dietary permissions that check on user will be captured as well. This goes with user info on password, as well as even detecting SCP script as well. This potential MITRE ATT&CK will be linked to file and directory discovery, as well as ingest to transfer. At the same time, it even captures commands that shows user informations, which could mean potential gathering of more user information, such as LSOF, LAS, DPKG, and SSH. This leads to potential MITRE ATT&CK on remote services on SSH, as well as data from local system attack. It even captures logs that attempt to access the etcpam.d that shows the password policies, and this could potentially refers to MITRE ATT&CK on password policy discovery. At the same time, it even captures logs that attempt to access the etc folder as well.